don't do that, Jim. All right, we want to, like, just minimize, right?
Self-destruct.
All right, self-destruct. Okay. Sure. I thought that was resume. All right, so
Resume is what you need to update after you hit the self-destruct button.
that's right. I'm Jim Adams. I'm Deputy Director of Planetary Science at NASA headquarters, and I got this idea from watching actually Ben on Space Vidcast a few weeks back. He showed the MSL EDL video, and I think probably scared most of his audience. Oh yeah. So what I thought I'd do is take a number of videos that I had, and this is not by any stretch all of the animations or videos from every landing we've ever made, but I thought what I'd do is show some recent animations of things that we've accomplished, at least in planetary science, and give you a sense of the different ways that we encounter stuff. And so what's not in here is like Apollo, or even something as distant as the near mission landing on Eros, but rather some more recent stuff. And I thought we'd just do a comparison, then see where the conversation went with regard to that, and possibly where the future might go. The thing is that for me to be able to load these, they were extremely large and they were bogging down this PC. Though my Mac worked fine, I might point out. We didn't want to unwire this PC and put the videos on, or put my Mac in its place. So what we're going to do is like flip back and forth between the PowerPoint and the landing animations, and we'll see how that goes. The first thing I thought I'd do is give you a little introduction to Titan. Titan, I guess I can't walk. Titan is a moon of Saturn, and it's enshrouded in this haze, this yellowish haze. If Titan were not in orbit around Saturn, it would be classified as a planet. It's that big. And so the Cassini mission has been doing flybys. I think we've done 75 encounters of Titan by now, and it has a radar on board. And one of the things that you see on Titan are these lakes. In fact, Titan is the only other body in the solar system that we know of that actually has liquid on its surface. Titan, in fact, has a hydrological cycle, just like we have on Earth. You know, evaporation, condensation, precipitation, and accumulation. Except that it isn't water, it's liquid methane. And so Titan is a very interesting place to explore, but very difficult to get to, not only because it's out at Saturn, but it's also enshrouded in this haze. The other part of the Cassini mission was, if you recall, it was called Cassini-Huygens. Huygens was a probe that landed on Titan. And there were some pretty innovative folks that took the Huygens data, if I can find it here. Anybody see Huygens? There we go. Huygens data, and integrated it into what looks like a heads-up display. And so there's lots of interesting stuff on this film. I'll try and explain some of it. It looks like it's about 8 minutes long. You see the green line? That's the altitude line. The parachute and the relative size to a person, as well as down on the surface, you can see a relative size to Mount Everest. As it comes in, it starts sending data back, linking data back through the Cassini spacecraft. And as each frame of data comes in, we collected it into the center there. And slowly, you can see the green line approaching the surface of the moon, of Titan. Let's see if I can, right in here, you can see we're coming down closer and closer towards the surface of Titan. And as we get in closer, you will see the resolution get better and better. And with that, I'll probably just shut up and let you watch it.
So the black on the circle is data dropout?
Is data that had not been collected yet. Correct. You can see they get filled in subsequent images. So in the case of the Huygens probe, it was all entry by a hypersonic parachute. There's enough of an atmosphere on Titan that we were able to slow the thing down, drop it off, and just do the entry by parachute. And you can actually see they even modeled the resonances in the lanyards. And the sound is supposed to tell you something, but I'm not exactly sure what. Titan is also an interesting planet in that it has the right pressure that you could walk on Titan. If you could stand the cold, you could walk on Titan without a pressure suit. So if we were to send an astronaut to Titan, he would need a temperature suit, not a pressure suit. I wouldn't even go that far, Ben. Its atmosphere is methane, so. No, you couldn't. That's correct. That's right. So thanks to some pretty innovative guys with ESA, they took this Huygens data and they made this video that we get to enjoy and use it as sort of a starting point for how we might do entry, descent, and landing in other places. The really disappointing thing is almost as soon as it touches down, the final image disappears. So you don't really get to enjoy it too much, but you can see that we're coming up closer and closer and getting better and better resolution of Titan, which in the time frame that we landed on Titan, it appeared to be fairly dry. I will remind people that that's also what we concluded about Mars after the Viking landers. So it's also kind of eerie the way it kind of just comes at you like that. You know, I think that they took the spin out. So no, I don't believe the spin was controlled. And what you see in the left-hand stripe there is a relative resolution from something that we all recognize on the moon. And you get the sense that Titan is a little bit more rocky, kind of flatter, more gravelly sort of place, at least in the region where we were taking our last pictures. Let's see. So that was the first image, or first video. Ah, that would make sense. It would tell us a lot about its velocity through the atmosphere. Thank you, chat room. So then the next thing that I thought I'd show you is not really a landing as much as it is an impact. But I thought I'd show you the difference between what we envisioned and what actually happened. So we have the Deep Impact mission, which slammed into the comet Tempel 1 a few years back. I can't remember exactly when, 2004 maybe. So I thought I'd show you the animation from that. Let's see. And it doesn't take as long. So there was a shepherding spacecraft which had all of the imagers on board, and it's separated from the impactor, which also was able to control its attitude. In fact, what really happened was we separated the impactor from the shepherding spacecraft and allowed the comet to run into the impactor rather than the impactor slamming into the comet. And there you get a sense of what it might have looked like from an animation standpoint. The shepherding spacecraft then continued on to fly by the comet, trying to resolve as much of the debris ejecta as possible so that we could do spectroscopy on it. And then it continued on its way. One of the really interesting things about the shepherding spacecraft for deep impact was it was later renamed Epoxy, and it was that spacecraft that flew by the comet Hartley 2 back in November and resolved those images that I showed you this morning with basketball-sized puffs of ice coming out of the comet. Now I have a 20-second video from the shepherding spacecraft that shows you exactly what we saw. So that was what we were supposed to have seen. And this is what we saw. So we didn't actually see the impactor at all. I'll see if I can replay that. Anybody know how to replay these things? Rewind? Oh, just click play again? Thanks. Didn't really get to see the impactor at all. It just went boom. And then we kicked all the ejecta up into the sunlight, and we blinded the camera, and then the spacecraft moved on. All right? So, in fact, we know exactly where we hit it, but we don't know how big a hole we made, and we really didn't get to look down inside of it. So what's really cool is on Monday night, the Stardust spacecraft, which flew through the tail of Comet Wild 1 and returned a sample some time ago, got redirected, and it is now, on Monday night, it's going to fly by this comet and hopefully get a peek inside the hole that we made. So, let's see here. So then the next thing I thought I'd show you, next encounter. Oops. Ah, our favorite, the MERS. So this is, I hope most of you have seen this one before. This is the Mars Explorer rover exploration rover landing.
We are now moving at a speed of 12,192 miles per hour. Downrange distance to landing site is 437 feet. Current altitude 8,000 feet. Moving at a speed of 173 miles per hour.
So we dropped off the heat shield.
Velocity.
I'll let the guy narrate.
Separation event has been detected. The radar is in lock, and we have a good solution on the ground.
I love that.
Expected retro rocket ignition on my mark. Mark. Getting confirmation from the spacecraft that retro rocket ignition has occurred. At this point in time, we should be on the ground. Now, 6 minutes, 37 seconds from atmosphere.
We still have to land right side up.
Indicates that the rover has landed face pedal down, which means right side up.
Yes.
And so we did that not only once, but we did it twice very successfully. The airbag technique seemed to be almost perfect for that size rover. And the rovers were supposed to last 90 days, and they last, you know, what is it now, going on 7 years or something like that. Just an incredible success for us. So our next landing on Mars was the Phoenix lander, which was not a rover, but it was a science laboratory. And so, because of that, had a very different landing technique. And I'll see if I can full screen this somehow. I'm reaching the limit of my capability. Oh, okay. Right here, fit to screen? Oh, full screen. Thank you, everybody. There we go. So it also had a cruise spacecraft, a cruise stage, which it separated from above the atmosphere, entered the atmosphere with a thermal heat shield, and then deployed a hypersonic parachute. I guess there's no sound on this one. Oops. Then, when it got close enough, it let go of the heat shield, the legs come down, and it fires a set of retro rockets. It lets go of the chute, drops, and ultimately says, oh, well, I better fire these things so I can land safely on the surface. A gutsy move. That's sort of the way Viking happened, although Viking went into orbit around Mars and then deployed from orbit. And then it deployed its solar arrays. One of the other interesting things about the solar arrays is after the Martian winter, we were able to find the solar arrays laying near the Phoenix lander, but not attached any longer. They had frozen and been, the lander had been basically frozen apart when it got encased in CO2 during the Martian winter. So I'll let it run the other minute or so. This is all about the science.
So was it buried in CO2 or
The CO2 accumulated around it. So when we dug down, they don't show it in the animation. When we dug down, we found white stuff, and the white stuff would sublimate away overnight. So we were pretty sure it was water, and then we put it into this mass spec, and we were able to determine that, yes, indeed, we had found water just under the surface of Mars. Now this was at the northern latitudes, but since then we've actually found fresh craters that have exposed water just a few centimeters under the surface where the Viking landers, in the region where the Viking landers had landed. What we found is that, the theme on Mars had been follow the water. We've now found it, and we're actually moving on to a theme on Mars that's follow the life. And so the next thing I wanted to show you had to do with how we might land the Mars Science Laboratory. Now remember, we used airbags for the MERs, and we used a sort of a direct inject technique for the Phoenix lander, but the Mars Science Laboratory is the largest, most sophisticated rover we've ever built, and it is too big for airbags and too big, too complicated to put a pallet with retro rockets underneath it. So we have this technique called the sky crane that you'll understand in a moment. So it too enters the Martian atmosphere, deploys a heat shield after it heats up, and then a hypersonic chute. And then when it gets close enough, the wheels come down instead of the legs, obviously. And then it lets go. But instead of the pallet being under the spacecraft, it's on top of the spacecraft. And the sky crane comes down to within the last 60 seconds or so of the descent, slowly hovers over the surface of Mars, and lowers the rover on a crane till it gently sets down. And then the lanyards are cut and the sky crane flies away. And the rover's set to begin its commissioning and science program. That's going to be a nail biter. So we launch MSL on November 25th of this year. It'll take about 9 months to get there, so in August of next year it will arrive at Mars. And hopefully, in the same way that everybody's been looking, everybody watched the Phoenix landing and the Mir landings, people will also be watching and wishing us success on the Mars Science Laboratory. During EDL, it's going to be skinny data, but mostly it's going to be accelerometry and some of the heat shield erosion data, but we're not going to be taking images on the way down. Yeah?
What is the level of confidence of that actually working with the engineers and the scientists? I mean, MSL doesn't have a backup like the two other Mars.
Right. Right, and we had 2 Vikings too.
Yeah, so how confident are they that this is going to work since there's no backup coming?
Well, I said it was going to be a nail biter. It's not a cakewalk, and there's a risk in the thing, although we've tried to drive all the risks we can identify to zero. The bottom line is something could go wrong. We could hit unusual turbulence. It could get downrange for some reason and land in a region where there's rough terrain. We'll just have to see how that goes. Yeah.
If the animation there is correct, you're going to be shooting a beam and then studying the cloud from a distance. What kind of concern for vision is there if you're in a dusty area moving across and you have some other kind of arrangements?
Well, there's enough instrumentation on board the MSL that they'll know to wait to actually take that sample. So the laser will vaporize a little bit of the rock, and then we'll measure the vapors that are released from within that rock, which, by the way, that's actually what they're after. They're not after the vaporized rock itself. They're actually after releasing the gas that's trapped inside the rock. And then we'll measure that with a gas spectrometer, or maybe it's a gas chromatograph. But we know enough about the weather to watch and wait before we actually start firing. Yeah. Right. So the question then becomes, and I have one more video to show, but I can show it later. I want to talk about Europa for a second. Actually, I'll go back and talk about Mars Science Laboratory in case you didn't hear what I had to say this morning. I have a steak dinner bet about whether or not the methane vents on Mars are either from biotic life or abiotic geologic activity. MSL won't tell us category 1 whether it's this or that, but it will definitely help us put a bounds on the probability that the methane vents are either from decomposing life matter or from geologic activity. Either way, that's going to be a big deal because right now we think there is no geologic activity on Mars, and we're pretty sure there's no life on Mars. So the real question is, where's this methane coming from? And MSL is going to help us with that. It turns out that another place in the solar system where there might be life is Europa, which is really a conundrum because if you go to Europa, it's all the way out to Jupiter. It's sitting in the radiation belts at Jupiter. In fact, if you could stand on the surface of Europa, you would receive a lethal dose of radiation in just 48 hours, 2 days. It's got kilometers thick ice shell. The whole thing is actually, we think, ice. And in fact, underneath that ice shell, scientists have calculated that there is 2 to 3 times as much water as there is on the surface of the Earth. So because it's liquid, because it's water, and because it's bathed in radiation, which releases oxygen into the water below. So we've got oxygenated warm water. We think there might be a possibility that maybe, kinda, there might be life inside of Europa. And so Europa is kind of like the place to go if you're an astrobiologist. Astrobiologists would be happy to go other places too, but this is sort of the Mount Everest of astrobiology. And so I'm curious to know if any of you have given any thought to how we might land on Europa or explore Europa. Sky crane? That's an idea.
We've been talking about the pusher down, having some sort of the lander generating heat and melting space.
Mm-hmm.
Is that been seriously
It's been thought about. Yeah.
impacted with the magnetic missile and then followed through the whole
And break it open. Yeah.
Yeah.
Splash down. In fact, one of the interesting things about Europa that we're beginning to understand is we really don't know that much about Europa. And we think that the surface is so rough that trying to land flat on Europa is going to be very nearly impossible. So you had an idea. Yeah, you were.
Well, I was gonna ask, is there anything on the surface that you could, get on, at least if you get to the surface, it's feasible, and then take some measurements from the surface, which could then help you figure out later on how the barrier goes down.
So,
Figure out what it's made from, if it's something that can do chemical reaction.
right. Well, that's actually not a bad idea. To go in multiple steps, maybe. Getting to Europa is, if you're a scientist, is like once in a generation kind of opportunity. But if Europa became the next Mars, if Europa, from a societal standpoint, we decided, well, that's where we want to go next, then we could determine that what we need is multiple missions to Europa.
You might have thought about using you use a space cell using radiation. Is there any way, if it's in that radiation field that you described, that they can use that as a power source already there?
For energy.
For energy to do whatever you need to go further down?
That's a thought, too.
That's free.
Is this being recorded? Yeah, we ought to have some scientists look at that, or engineers anyway. Well, I'll tell you, what I thought I'd do is I'd show you the James Cameron concept to wrap this up, and then we could have whatever sort of dialogue you all want to have. I thought maybe this might stimulate some thinking and some conversation. So a while back there was, I've got to find it here. In fact, James Cameron helped us with this video.
Europa.
Uh-oh. Maybe that's why it's not working so well. Did I accidentally, there we go.
A mission to explore under the ice of Europa would be the ultimate robotic challenge.
I don't have to turn the volume up.
During the landing, the team in mission control would pretty much be along for the ride.
Whoa.
Europa is so far away that even at the speed of light, it would take more than an hour for the command just to reach the vehicle. It's really on its own. It has to be smart enough to avoid terrain hazards and to find a good landing site on the ice. Now we have enough to get through the ice. You need a melt probe. It's basically a nuclear heated torpedo. The ice could be anywhere from 3 to 16 miles deep. Week after week, the melt probe will sink of its own weight through the ancient ice. Until finally, now, what are you going to do when you reach the surface of that ocean? You need an AUV, an autonomous underwater vehicle. It needs to be one smart puppy, able to navigate and make decisions on its own in an alien ocean. Europa has internal heat. It may well have hydrothermal venting. If it does, and if the chemistry is right,
it will have an enormous impact on humanity if we find life in an ocean on another world.
I'll tell you a quick story. We were doing some market research a while back, and I went to Sacramento for one of these focus sessions. And what you do is you sit behind a view screen, a glass wall, a mirrored glass wall, and a facilitator engages the audience in a conversation about whatever topic you pay them to facilitate about. And so we were talking about the search for life in the solar system. And the facilitator said, well, would it be worth it to you? Would it be an important thing for humanity to go to Europa and to find life? And everybody, just about everybody in the audience agreed that that would be a really important thing to do. And then he showed him this picture and these lines, and he said, suppose we went to the surface of Europa and brought back some of this brown stuff, and we found out it was algae. What would you think then? And one high school girl chimed in and she said, well, then I'm not interested. You have to bring me back a puppy. But what I would encourage you all to do is to think about, what does it mean to you personally to find out that we're not alone? Or maybe to find out that we are alone. It's hard to prove a negative. But the bottom line is that that's one of the major driving questions that we have in planetary science today. And I'm hopeful that that's a thing that will inspire children to want to work for NASA and to work in aerospace for generations to come. Because this isn't going to happen tomorrow. I'd be fortunate if it happens in my son's lifetime. But someday we will move the bubble of human influence out beyond low Earth orbit, out beyond the moon, and out beyond Mars to begin to understand the solar system that we've been blessed to be put in. So with that, I thought I'd open it for questions and discussion. Ben. Yeah, that's a really good question. So the first question we have an answer to. The second question we don't have an answer to. The first question is, where does the sky crane go after it lets go of MSL? And the answer is, we try and fly it as far away as possible so that when it touches down, basically it runs out of fuel and crashes. When it touches down, it does not kick up debris that would interfere with the deployment of the mechanisms and the instruments that you saw have to happen next in the commissioning sequence. The second question is, how do you communicate through that much ice? Well, you know, having a submarine communicate from the bottom of the ocean to the surface is a challenge even here on Earth. So there are engineers that are thinking about that. And perhaps somebody who's still in school today might have an idea. One idea that I've heard is that you leave something on the surface. As that probe melts its way through, it deploys out a fiber optic cable. And so then the submarine is actually unreeling a fiber optic cable as it swims around inside of Europa. That's kind of limiting. It'd be nice if we could do something that's a little more like Wi-Fi, but we'll have to see how that plays out. Yeah.
What do you think about the implications of planetary protection for exploring Europa? I mean, we really have this ocean, and for the spacecraft in it, if there's any type of earth-based computing,
Correct. Yeah. That's a pretty big deal. We have a planetary protection initiative within NASA, and one of the things, for example, Juno is going to Jupiter later this year, and it won't arrive till 2015. But when we finally decommission Juno, we have to make sure that it doesn't contact Europa, specifically so that when and if we ever go to Europa and begin to look for life, that we're not finding our own life. We don't find our own DNA. We find alien DNA. And so when we would send a mission like that you just saw, conceptual from the video, to Europa, we would for sure have to decontaminate it somehow before it left Earth. And there are lots of ways that we're thinking about that. One of the ways is the way we did with Viking, which just before launch, we stuck the whole thing in an oven and baked it out. So brute force. There are other ways, too. You could hang in a radiation belt long enough so that you know that you killed 99.9% of the microbes that are typical to Earth.
If Europa is such a big deal and such a milestone, why wasn't it done? Why wasn't something started sooner? I guess is what I could say, at the very least. And how sure are we that it's completely covered in ice to be confident enough to actually send something that is water ready? I mean, wouldn't you have to provide for all possibilities if you don't know that much about it?
Well, so there is a debate about whether or not there's actually a core to Europa, like a solid core. But we're pretty sure, based on the ground-based measurements that we've made, Hubble's measurements, and the flybys from the Voyagers, of what the content of Europa is, its size, and its and the fact that it's totally frozen. It doesn't have any surface elements that are ground-based. So, and there was another mission that was out at Jupiter as well that did some mapping of Europa, and I can't remember the name of it. Maybe the chat room knows. So, yeah, so those would be problems to be considered before we would design an architecture to go.
Recently approved a joint NASA-ESA mission that one of the objectives will be surveying Europa.
If it's ultimately selected, then
So it's not.
yeah, there's a joint competition ongoing between NASA or not between NASA, amongst the scientists. And NASA and ESA are kind of doing the dance right now to figure out if we've got a partnership that would work. They would really like to go to Ganymede, the Europeans, and the United States would really like to go to Europa. We're looking at ways that we might be able to do both.
Yeah, that's what I guess it sounded more definite.
Well, we're getting close. We're getting close. And there's also a lot of wishful thinking out there. So.
You could then presumably do radar imaging.
Mm-hmm.
The concept of isolines to get better idea of those.
That's correct. Yeah. Did I see a raised hand, or am I just? Yeah. There we go.
So, what are some ways to figure out like what's gas, what's ice, whatever is on the planet?
What are some of the ways that we do that with spectroscopy? So we can look at the way the light bounces back off of the surface, and it'll tell us a great deal about the content that made that reflection. The other way is to actually sample some of it, but we're not close enough to do that. I had a scientist friend at Marshall Space Flight Center, and she says really the only way to know that it's water is to taste it. And in some ways, she's absolutely right. The best way to confirm that we had water on Mars was to send an instrument, pick some up, and put it in the instrument and analyze it. So, well, you've all been really patient. I kind of threw this together at the last minute. I hope it was informative and maybe stimulate some thinking. So, thank you. One more?
Would you, just because, you know, we're tying in with the world social media and NASA and everything, would you guys ever think about putting like a Twitter, Facebook competition for schools to come up with a mission to Europa, just to see what kind of ideas we generate from that kind of generation?
Well, that would be really cool. That would be something that we could think about, just as a Gedanken exercise to think about ways that we might explore Europa. It would require the students to learn about Europa in advance, which would be really exciting. The fact that we could, I would think about that. Yeah.
Kind of add to that, they have it at the University of Houston here. It's the Mars Rover Celebration, and it occurs every year. The kids over the fall, they actually learn about Mars in detail. It's 3rd to 8th graders, and they build their own Mars rovers. It's either like a solar power kit or RC kit or a freeform, depending on what category you enter. And normally have it spend $25 for a week, something like that. And they just had it like 2 or 3 weekends ago here at the University of Houston, and I actually with some of the judges. And you know, these kids have to learn everything about Mars and figure out. I mean, these kids came up with really intelligent things like creating mini robots to go inside the rocket to figure out the environments in the rocket. You know, they can use future habitats while learning about what's in them, all these sorts of things. So you could base it on something like that for whatever kind you wanted.
Right, and we've done things like that in the past, where depending upon the level of the students and how many, sometimes we've invited the winners to come and brief us at NASA headquarters or at a NASA field center, so that we can learn from the ideas that come out of these ideas, and as well as inspire the kids to keep on going. So, more questions, or should I cut this off? I think we're done. Wayne, did you want to talk about commercial space?
I think it's time we have
Okay. All right. Well, thank you, everybody, for your time. It was a great session.